And I think we are just in time. If it worked. Did it work? Upfield, don't match up. Yep. Excellent connection. That's weird. Let's reload this page, just in case. Meanwhile, is the audio loud enough? Yeah. I just need to stop mumbling, I suppose. Is the source correct? Yeah. That's it. No. No, so that's not the correct source. Why is that? Oh! Yeah, of course. That should be better. Let's... Oh! 1, 2, yeah. I think the audio should be... Okay, that's a bit too much. 1, 2, 3, 4. Yeah. So, where is YouTube at? Okay. Okay, I think we're good to go. I think I should probably try to find a way to offload some of the video processing to another machine, because streaming to both YouTube and Twitch with OBS and stuff, it just makes my machine melt. Anyway, so today I wanted to have a look at this thing, which well, I think some of you may know about this. That's a replay some chips in all Apple computers, like the LCs. Basically, it's the chip that monitors the clock battery and switches the power to egress from the battery to the power supply, and monitors it to trigger a reset if the voltage is too low or whatever. So I designed the board and I tested the design, and it works. But then I made some more, and I wanted to maybe sell them. So, but before selling them, I wanted to make sure they actually work. So I did come up with a test equipment, which is this thing. Hopefully we'll find a better way to wire this, because that's really great for testing, but not as much for actually testing stuff using it. So yeah, I have these proto shields that might be suitable, so I just use this Arduino clone and stick this in, and no more wires basically. except FreeSync doesn't have the component for this. It does have some Arduino shields, but it's not exactly Proto shields, but it's not exactly this one. So I actually made some attempts to add it, but it didn't really work out correctly yet. But well, I'm not sure I want to spend more time making these. Maybe I just use whatever is available and adapt the actual wiring of mine to suit this one. I kind of like this one because it really has more pads than the other ones. I mean the others are nice and but yeah, this one leaves more room for actual components and wiring. Anyway, so if I go to here, so there you actually see the same thing but inside FreeSync, which is a nice way of documenting breadboard stuff. So I didn't finish the schematic view, but well, the schematic, well, and I also did a where is it? A start for the proto board version. Oh, I minimized. I think I minimized it. Yeah. So that's, yeah, I cleaned stuff up to basically use some proto board as the less well, the most the one with the most pads available. But you see there's some components I don't have on my proto shield here, so anyway, so that we can do later, but I wanted to first finish the test code I wrote here because I want to test as much as as possible all the features of the chip I want to replace. I mean, I know it works, but I want to make sure I didn't miss soldering one pad or added any bridge or whatever, solder bridge. So yeah, that's what I want to do tonight. Hi, Negvosa. Hi, on Twitch. So I'm both on Twitch and YouTube at once. So if you hear me mention someone that you don't see in the chat, well, that's probably on the other platform. So here, yeah, I can zoom the text. It's an old version of the Arduino IDE, but only the newer version don't support control wheel to zoom in the text, which at first I found it quite annoying because you sometimes do it without wanting it. But I mean, for demonstrating stuff, it's quite easy to zoom stuff. You don't have to go to the settings and whatever. Anyway, so that's the current output from the board here. So basically, if I reset here, you see it just outputs the name of the software, just in case you plug it and you don't know what it's supposed to do, and then it's waiting for something to do. I need to let's put a chip on first. This cam, yeah. Well, I had to rotate the thing. I'm used to having it the other way, but the cable is a bit short here, so so that dot here is the pin 1, and I marked the pin 1 here with a little dab of ink. So yeah, I need to pull this lever here to spread the pins, the contacts, from this slice of PCI socket. Yes, it's a slice of PCI socket that I use as a test socket, which works quite well. I mean, sometimes it doesn't work first time, but you just retry and that's it. So yeah, I could probably switch to the endoscope just to give you a closer view here. So that's usually mounted on the microscope, but yeah, so that's that slice of PCI socket with 4 contacts on each side, and yeah, I did this thing to spread the contacts, so you can insert and remove the chip, and then you push it back to lock it in place. Yeah, and that's the start button to start the test, and this one simulates a force reset, if I remember correctly. It's been some months since I worked on it, so yeah. Let's put this back in here. So now that I've installed a circuit in the test socket, I can push this button here, and you see testing, and it spits a lot of text because it's debug code to see how it works. So currently there are like 3 tests. I will have to check because I don't really remember exactly which one do what. Then passed. So yeah, basically if I scroll upward, I simulate some ramping up of the voltages on some of the input pins. So that's basically the parameters, and then I'm reading the states and of the output pins here, so that those 2 are digital outputs, and that's the output from the switch. So that's the pin that's supposed to power the Y chip in the Mac. And well, I just calculate how much I'm supposed to have there, and well, if it deviates from a significant amount, well, I'll just fail the test. There's at least one test which needs some timing, because well, the delayed is not immediate when well, it's down immediately, but then it waits sometimes before raising up. So yeah, and also yeah, I can force, if I start another test and in the middle of the test I just push the manual reset. Yeah, you see it complains because here on this test it actually simulates the manual reset, but since I actually pushed it before it was actually doing it, then reset was low before it was supposed to. So yeah, at least this test works. Yeah, I'll just put the other chips in the bag because they're tiny. They're really tiny. Yeah. Oh, YouTube link. Yeah, that was announced on Mastodon. Hold on. Yeah, here it is. Copy link. So if I go over the current code, well, I remodeled it several times already. These are the usual Arduino defines. So you tell, well, this is actually pin 11, this is pin 10, and whatever. So these are the outputs to the chip. So they are connected to actual inputs of the chip. These are yeah, digital outputs. So when you want to force a reset, and these two are for the LEDs. So there's a green LED for good and a red LED for failed tests. And same with inputs. So that's the official names, at least on the replacement chip I used, because I had to replace a SOIC 8 chip with another SOIC 8 chip, because there are some other chips which do the same function with a smaller package, but they actually don't do exactly the correct stuff. So well, or they don't support 5 volts, because there are newer chips for newer designs which are supposed to be 3.3 volts. So anyway, I had to squeeze stuff on a small board to fit a SOIC chip on a SOIC place. And yeah, those are the 5 inputs that we monitor. So Vout is the out of the chip outputs. Those are the actually to monitor the outputs that we generate, just to make sure that like if you want to do 3.3 volts and actually you read it's like 2 volts, well, this means there's too much current being pulled or whatever, so you can actually raise some warning and say, oh, there's something wrong. Yeah, those are power fail input. So same here, we actually generate a power fail input signal, and then we monitor it. I'm not sure the current code actually does anything with, well, for VCC, yes, it reads it. I mean Vout, but maybe not the other ones. And ground sense, that's just to make sure the the chip itself actually doesn't use too much current, because I ordered chips from AliExpress, or was it eBay? I don't remember. I had like, well, I had one order that got cancelled or something. Well, actually, it waited for like a month, and then I noticed there was some message in the message center on AliExpress. I never go there, saying, "Oh, I don't have the chip anymore. Can you cancel the order or whatever?" And then after a month, it got automatically canceled or whatever. Another one, I think they never arrived or something. No, actually, the post office said they actually arrived in my mailbox, and then it was like after a vacation or something, on Christmas Day, or well, around, and then I actually arrived like 3 hours after it was supposed to be delivered in my mailbox, and actually it wasn't there, so it like disappears in a 3 hours window. Well, anyway, so I never got it, and of course I never got any refund. Oh well. And then the third batch I tried to order, it was just, it looked like it worked partially, like it did some switching or whatever, but then the manual reset input didn't work and stuff like that. So this test actually also tests the replacement chip on the board to make sure it actually conforms to what we want, and also well, this failed chip actually consumed way too much power, which is not a great idea when you power things on the battery, which is basically what this chip is supposed to do. So yeah. So the whole chip is actually not directly tied to ground. If I go to the schematic, there are some mosquitoes in here. I think I have to grab the racket here. I just hope that's enough to frighten them. Not sure. Yeah, of course. G and D. Oh yeah. It's probably easier on the other implementation if I didn't remove everything. Yeah. No, that's not it. Wait. It was supposed to go. Merge. I think I missed some. Which input is it? Ground side's A0. So on this one, A0 is here. So it's the blue wire here. Okay, yeah. So here you see, I have actually two. Well, on the breadboard is on fretting it's deep ICs, but it's actually the test socket, and well, there are two wirings because the replacement chip I used doesn't have the same pinout, else I wouldn't really need an interposer board. So I just accommodated for both pinouts to simplify testing. So yeah, that's the ground of the chip itself, and it doesn't actually go to ground here, to the ground rail, but it goes to ground via this resistor, which is like 100 ohm or whatever. So if the chip consumes too much power, well, there will be some voltages here that we can monitor and raise an error saying, well, this chip consumes too much power. So it's basically a shunt resistor to measure the current. How is it ground? Yeah, this one is not connected here. 10 ohm. Is it this one? No. 100. Ah, it's that one. Okay, it's this resistor here. I should probably finish the schematics. Anyway. And then there are some weird code if you're not used to writing C. Well, this is this one is just to define a number of iterations for the ramps, because we don't want to take an infinite amount of time to ramp up to 5 volt or whatever. So it just simulates 10 steps to go from the start to the end of the ramp. That's for the calculation here. So I can easily say I want like 3.3 volts, and it would just calculate how much the value to send to the ADC, like right analog on the Arduino, and same for the other way, and also PWM. PWM, well, because there is no proper digital to analog output on the Arduino, so you actually have to fake it with the, yeah, I'm missing the caps here. Yeah, here. So here they are like stacked all three together, but basically there's yeah, we're using some caps to filter the PWM outputs, and then since we know these chips don't really take much current, this is way enough to simulate an analog signal, so we don't really need any DAC or whatever. I just had to make some tests to find a suitable value for the capacitors, but yeah, it works quite well. And then there are some definitions of the channels, because I wanted to have the same code for each channel for the ramps and stuff like that. There are probably some stuff I don't really need, but well. Yeah, also this defines the link from the output and the monitor input for each channel, and then this defines the data for the ramp, like which channel it applies, how much we add to each step, and the start value, stop value, or whatever. And it's not really finished, I think. Anyway, I'm not even sure I'm using it yet. Yeah, and then some function for each test. So yeah, because the manual reset test is different than just a ramp. And also there are some thresholds involved. So, and also some of the chips I can use actually differ on the way they work. So the first time you actually have to raise one of the inputs and then the other one, and else it doesn't really work. So that's basically you don't waste the battery until the first use for a new product, which is great, but well, Yeah, so RAMs. Yeah, okay, so these are all the different tests that we run. The manual reset, that's the last test. And yeah, and then power fail input, reset 1, reset 2. So power fail input, basically we set VCC, so that's the step 0. -1. Oh, well, we set VCC to 5 volts, 0 as the battery, but we don't really care. And then we start from 0 to 5 volts with the power fail input. And well, that's just to calculate how much to add for each iteration. So if I want to change to 20 iterations, I don't have to edit all the text here. Then for reset, we do another ramp, so we start from 5 volts. Still 0 for the battery, and PFI we don't really care. I don't think I really need to test multiple inputs at once, except for VCC and VBAT, because there's the switch that's occurring at some threshold. But then, yeah, that's the reset. Another one. Yeah, so that's to test if reset actually works also with no VCC but VBAT. Supposedly, I think it should stay with reset output low. So yeah, and then there are some variables for the state machine, because there are some some things like if one of the tests fail, we just fail everything, because there's no point in running other tests. Yeah, and also I just flash the LEDs between each test, so you can see there's some progress at least. But then when we have decided that it's failed, or well, we just set the LEDs accordingly. Yeah, that's on every test. We just make sure the chip doesn't eat too much current. Yeah. Nope, missed the mosquito. Ah, crap. So these are the functions that implement all the tests for each step of the ramps. So that's the manual reset test. I use a variable called state here, which depends on the test, but and then in there I encode some states. Well, here if we already have had the manual reset input that's went low, and then we flip a bit when it goes back up, and yeah, because reset should go low when MR is low, and then it should go up after a while after MR goes up again. So reset should not be low if MR never has been low before, and yeah. And there's some debug code. Anyway, so this test works. It's just a bit slow because we have to wait for the reset signal, so I just left it as the last one. And yeah, so after each iteration of the step, well, each test has a number of iterations, so each time we run this function or the next one, depending on which test, not this one, yeah, this one. And this one is just a generic function to increment the step on each of the ramps we defined. So all this should work. I think I just need to actually write the other ramps and for the other tests. Okay, so that's some previous code that should probably be removed at some point. And well, when we have a failed test or we just complete, we just go back to idle and leave the LEDs as is. And that's the setup function, the classic Arduino setup function. So that's where everything begins. It's not like main on regular computers. But yeah, so this function is actually executed each time you push the reset button or you power the Arduino on. We initialize the serial output, and then we make sure all the inputs are actually inputs and outputs are actually outputs. All pins are input by default, and so you don't, well, just in case you wire something incorrectly or you don't know or you later want to make it an input, well, at least being an input doesn't really cause any trouble because it's it has a higher impedance than actually being an output, which usually forces the level to either ground or 5 volt. And yeah, reset these two, we need a pull up, and this one as well, so you don't have to add a resistor for the push button because it's already internal to the microcontroller. Yeah, and then we just print the version string, and yeah, and we just wait for stuff. So this just sets up for the default state, and then loop is what the Arduino framework calls each time. So you just the loop function is called inside the loop. That's weird, but yeah. Current is actually the current test. So I think by default it goes to -1 or something. Yeah, and probably idle just, yeah, current, that's another current. Okay, well, yeah, okay, when we finish testing a chip, we just go back to -1 as the current test. So it's basically the index inside the tests this array. except, well, -1 is just invalid here. So we just wait for the start button to be pushed. If we are currently testing, so current is more than -1. Well, that's if it's the next test which isn't in the list, so it's actually the count of the test, but since it's 0 base, it's outside of the list. It means we have finished all the tests, so and either we pass or fail, or else it means we have a test to handle. So we just call the handler function for the current test with the state variable and everything that's that needs to be passed. Current, yeah. So and okay, yeah, and the handler function returns either, I think it don't remember if, yeah, it returns a boolean, so it returns true if the test is finished. So if it's not finished, we just return false, meaning that we are still, the next iteration would still be on this test and not the next one. So if the current test is finished, then we go to the next one. We prepare for the next one, and then if it's the last one, well, it's after the last one, then it means we have passed or failed all the tests. Anyway, so that's the current code. I should probably yeah, I should probably open the datasheet for the chip. So yeah, that's the family of the chip I use. They don't have all the required features, so it's a bit well, it took me some time to find the correct one and make sure it had all the correct feature. Also because I didn't really know, we didn't really have the datasheet for the original chip, I mean the Apple chip. We just had the reference that was a Apple specific reference. It probably was some kind of chip like this that used to be made. I think some of like the Beaumark schematics actually mention some other references, but then it's like you don't find any datasheet for them either. So so I actually had to build a framework with the breadboard and stuff to actually characterize the chip, to find which pin was actually an output, what it did and whatnot. And I actually documented that. Where was that? Yeah. Because I noticed people like Kai Robinson, who did some reloaded Macintosh boards and other stuff. He started documenting some of the Apple custom ICs with the pinouts and everything. Like yeah, well, it's on a Google Sheets. It's not my favorite platform, but I just wait for it to load. But yeah, so there's a list of all the chips and what we know they do, if we do have a pinout available, reverse engineer from the schematics or some other documentation. And then for each documented chip we have the pinout like so, with a clever use of spreadsheets with merged cells and colors and everything. So well, I just thought let's do that for Egret first, because I first started looking at Egret and I haven't really finished that, but I think we can probably make replacement chips for that. But spoilers. Reconnecting. Google. Some fonts could not be loaded. I don't really care about which fonts you use. So yeah, I started adding Egret there, and then, well, since I also did this 0120 or whatever Apple calls it, 343S0120, whatever, some people actually started trying to reverse engineer it, but it was not all correct, so I just added this here. But yeah, so basically that's the pinout of the original chip, and for each of the board it was in there was I added some comments, because not all boards use all features, like manual reset input. Like on my LC3s, it's like tied to some weird chip that does video. I don't really know why, but well, it's there. So maybe I don't know, maybe Apple uses some palette register to trigger a reset. That's weird, but why not? And yeah, so you start looking at schematics and you say, well, on this board this pin is ground, this pin is ground, this pin is ground, on this board is ground as well, so that's probably ground for the chip, because it's always ground. But for these pins, well, this is grounded, this is grounded, on this board it's grounded, but on this one is tied to something else, so it's probably not ground. So yeah, I can probably share the link to it on the chat. Anyone with this link? Yeah. Oh gosh, it still hasn't finished loading. Let me get some more water. Sorry, sharing is unavailable at this time. What? What the? Oh, okay, that's probably because I switched account for YouTube, and so the other YouTube account doesn't own this Google Sheet. Or crap. Okay, I'll add it to the video description, I guess, later on. And that's the Arduino pinout. In case you don't know about it, it's quite well documented. Most of the pins come from the microcontroller directly, but some come from other stuff, and as on pretty much every microcontroller, they can have multiple functions, so that's why you have some different colors in here, and you have like it can do PWM. These on the left can do analog input, so A0, A1, but they can also be digital output inputs. So yeah. So depending on what you want to do, you actually need to think about which pin you actually want to use, because you can use this one because of this, because of that, and so yeah. So basically I need to write more tests. In here, and I think, yeah, so on each step it just dumps the state, expected V out. Mosquitoes. I'm currently at Fabrico, which is a nice place. We have a fab lab, we have some other spaces. Yeah, so basically we read the V out, and we calculate how much we should have, but we don't really check for it there. Do ramp, yeah, and this one doesn't, it won't test anyway, unless maybe no, there's no channel specific stuff in here. Oh, hello Medbell. Mosquitoes inside, yeah, because the windows open, and so the blinds are hollow, so they can't come in. Hello Tregui, bonjour. Bonsoir, c'est vrai qu'il est tard. So so I have one test for peripheral input, two tests for reset, yeah, on VCC and VBAT. How does it test for reset? In reset tutorial, I didn't highlight. Yeah, so these tests are not really testing much yet. I should probably implement that first. Yeah, expected V out. Where is that? Oh yeah, okay. Also, yeah, but if I want to compare something to this, I will need something in volts as a float. So except the current, the state of the ramp, I think it's not in volts. It's in value of the PWM or whatever. No, ADC. Yeah, okay. ADC bits. V. So yeah, that's V. That should be the current. So yeah, the tests don't have. They are not declared as const because there are actually some variables inside these structs. So the I think it's do ramp. Yep. V. Yeah. Okay. So V plus equals delta, and we save back the local value to the ramp inside the test. So yeah, I need to not PWM but the other one, ADC to V. Yeah. So expected V out. Well, we can always compare because yeah. Yeah. If we don't have anything on either VCC or VBAT, then there must be 0 anyway on V out, so the expected value is still valid. Expected, I should probably do this here. So so I'll just do the test after each ramping up on each channel. So V, no, that's the oh, do I need to I need to cache these, I think, because I can't really compare anything correctly because I need both the VCC and VBAT values. Measure V. No, that's yeah, VCC. Oh dear, this is getting convoluted. Yeah. And that's not entirely true, because there's some threshold as well, so I'll have to fix that, I think. But anyway, so if we are on VCC here of, or whatever, measure VCC equals I think I should probably maybe I should read also PFO. Anyway, where do I? This one. Let's get this out of the way. It's used. PFO. Yeah, we don't actually test for PFO either. R1. What is this one doing? Is this one used? Or I'm not entirely sure why I have this here. Anyway, so oh, I swapped these. So the where's the data sheet? Vout page 9, which will happen to be page 11 or what? Vout, that's on. Oh no, that's actually on page 9. Wow. When VCC is above the switch over voltage VSO, Vout is connected to VCC through a P-channel MOSFET switch. While VCC falls below VSO, VBAT connects to Vout. So VSO, the switchover, and I think it depends on the chip reference. So we might actually need to test several versions, or 2.4. cartridge switch. Power down, power up. Wait. What the VRST? Oh yeah, okay. There's actually a threshold to the threshold. So VRST, okay, yeah. And it also depends on the reference. I don't remember which one. Oh yeah, 704. Well, I think we'll have to. Yeah, we'll just have to handle both. So so basically. If this is above VSO, yeah. So power down, power up. So that's the same. That's exactly the same. Where did they special case this? That's weird. So if VBAT is below the reset, if so basically VSO is max of, well, no, minimum. No, that's it. Yeah. Where is it? Where is this mosquito? Come here. I just want to hurt you. I mean, yeah. VBAT is lower. So, yeah. So yeah, basically it's mean of VBAT and VRST, and VRST is 4.25 to 4.75. Yeah. So in any case, expected VL, so if VCC is above 4.75, VL should be VCC. If VCC is got it. Now I have to clean my hand. Are these cases dry yet? Yeah. That's some other stuff. I managed to open some PowerBook batteries, and I think I found a way to do this quite cleanly. I mean, much better than anything else I've seen with Dremels and stuff. So yeah, and well, the few dents I have is because I didn't know exactly what was behind or whatever. So I mean, the second one I open will be probably much cleaner. Anyway, so I emptied them. I kept the BMS and stuff, but I just dumped the cells to the recycling. So that's for the PowerBook 520, and that's for the PowerBook 100 series. I do intend to find a way to replace the inside without having to do spot welding or whatever, because I don't want to just leave brand new cells inside for a few uses. So I mean, I want to be able to just open the case, pop the cells in, use it, and pop the cells out to use on other batteries. Anyway, back to the topic. Mosquitoes are our friends. Not exactly, Medbear. Yeah. So so when it's between 4.25, 4.2, 4.75, we might actually have VCC equals either VBAT or Vout equals either VCC or VBAT, whichever. But then below this, Vout should be VBAT in any case, with a margin because of measurement errors and whatnot. So the code will probably be a bit ugly. Yeah, I should probably just copy this, measure it. Yeah, just measure the out. Yeah, there might be some delay, but well, I think it should work. So we already have the conversion to volts here. If actually, yeah. I probably need parentheses. So I do something here. Too smart. Let's edit or else if I don't like it because it's not aligned, but well, if measured VCC is above I should probably have some 0.2, let's say. There. And else if no, actually I need to do this test inside, because else yeah. Yeah, for each case as yeah, for clarity I just use the same indentation for the third test. Delay. I should probably. I should probably move this above. Yeah. There. And the delay before measuring stuff. Yeah. Measure. Let's add PFO. Oh no, PFO. It's a digital input. Yeah, well, we'll deal with it later. So if VCC is below there, measure at V out. Can I do a different? Yeah. Apps. Do I have ABS here? Yeah, it should be actually. Yeah, I can do that. Measure V bat. That's the casing, yeah. So the absolute value of the difference, if it's greater than say 0.5, that's already quite much. But I think I've noticed some. Well, there's also some voltage drop from inside the chip, so the output is not always exactly the input anyway. Serial.println. should probably fail the test, but well. The out how to say that in English? Should be the bet. Then here the hat should be VCC. So same here. Yeah, it should be VCC. And then well, it should be if it's both two different than VBET and VCC, well then and this should be VCC or V. Okay. I failed the test. Let's see if I actually have something working. I think it fail equals to return true. Yeah, that's verbose, but yeah, let's see if this compiles already. Of course, my CPU is already busy streaming, so it can take a while. Oops. Bad syntax. I probably missed some semicolon or something. Expected before, or maybe mismatched parentheses. Measured VCC equals, okay. Oh, that's here. For both expected before, 1, 2, 1, 2. Oh yeah, there's one extra. How did I do that? Oh yeah, because I removed the max here. Expected. Yeah, okay. Actually, it seems I don't really even use expected V out then. Yeah, because the expected value is not really correct anyway. well, I'm lazy. Same color, what? Same color as Amiga Guru. Oh yeah, the red text on black background, yeah. Let's see if that's any better. It's not the most comfortable place to code because the bench is a bit too high, or the chair is a bit too low, whichever. Compile, and it's flashing. Yeah, téléversement terminé. Upload is done. So if I go back to the serial console and I start the test, let's see. Oh, there's okay. Failed. So there's a Vout should be VBAT. So that's test 0 done. So that's the test 1. So that's the second test. Expected. I should probably dump all the measured values instead of this expected thing that's not useful. Yeah. Measured VBAT, measured Vout, measured VCC. Well, yeah, V is the, yeah, whatever. Whichever, it doesn't really matter. Okay, let's test again. Oh, yeah, I should probably remove some of the tabulations because it's, yeah, let's remove one. Anyway, test 1 done. Right, I'm missing the ln. Let's just print an empty string with the yeah, should be I can scroll horizontally. Vout should be VBAT, so we have VCC equals 1.1, which is really low. VBAT equals 0. Vout is 0.69. Yeah, it doesn't really work like specified. I mean, PFO VCC VRST PFO. They don't show Vout actually on the chronograms. waveform. VC false beam plus hysteresis, and yeah, there's an hysteresis as well. Feedback may exceed VCC, connect to VCC. Yeah, when VCC is above switchover voltage, yeah, disconnected to VCC. Yeah, I think I probably have to relax the test, because those are actually genuine ICs ordered through Mouser, yeah, Mouser, because they didn't have it at Radiosphere. So yeah, that's real ones, not fake. I hope, but then Vout should just be 0, because VBAT is 0 and VCC is below. Oh wait, no. VCC falls below. Well, it's below VBAT because it's 0. So that's weird. Let's make that a warning for now. Actually, I know it's ugly, but I don't like having to waste 2 lines just for that. And also it's easier to just comment 1 single line instead of 2 when you want to change that. Yeah. Bye, Mabel. Okay. Okay, so now we have VCC rising here. Oh no, VBAT is, well, VBAT is 0 anyway. Yeah, it's above VBAT, so no, actually that's wrong. Measure actually no, if below, then it should be VCC if VCC is above VBAT. So this test is wrong. Yeah, it's actually more complex than that. Yeah. Undo. So if measure VCC yeah, it should be either VBATS or VCC if well, that's the problem. There's some hysteresis, so it might actually not work. So if measure VCC let's see. What? Expectation function. I forgot to close something. Yeah, of course. I see mosquito. Oh yeah, I forgot to paste the link on Virtual Labs Discord. So yeah, let's see. Let's test again. I think we don't have any warning here. So the out, that's the PF power fail test. The out rising from 0 and 1. Oh yeah, 0.5. Yeah, it's closer. And at some point I should probably have something like crossing, having V out going down and V bat up, or and the other way, because here I just test with the battery as 0 and then there I have both rising. This is, oh, that can be. I probably swapped some stuff here. VBAT, VCC. What the? What happened? VCC, measure VCC. Ramp out. No, that can be, right? Well, VCC should not be 0. What the? Oh no, right. V out, that's the out. Ah, I don't like that. The output should be last. That's confusing me. Yeah. So yeah, here I'm just ramping up VCC and then I'm ramping up VBAT, but with the other input as 0. So I need to check the interaction between the two, but at least there the test, the warnings don't show up. So yeah, that's what we should do now. Have another ramp, except I have like RST1, RST2. Missed it. Ah! I hate mosquitoes. Reset. Yeah, I should also check the status of the reset output at some point, but well. RST3, whatever. So this one had VBAT going up to 5 volts, so can I do that? We'll see. So I'll just be going from yeah, because VBAT ended up at 5, so I'll just go down from 5 to 0, and then adding a ramping up of VCC there. That should work, and then I just have I should probably make a macro to avoid this count off here, but well, that should do it. Let's see what we have. So this new test should have VCC going up from 0 to 5 volts, while VBAT drops from 5 to 0. So there should be some interesting situation when they cross. And yeah. Bzz. Bzz. Where is it? Ah. I think the next stream will be let's chase mosquitoes. Maybe I should make an Arduino controlled racket thingy. I don't know. That might end up being dangerous. Yeah. Serial console. RAM test 4. Okay. So here you see that's the ramp. So there's only one ramp going on for the first test, but this one has both ramps running. So we have VBAT from 5 volts to 4.5, 3.97, going into 0, and then VCC going up from 0. So at first we have V out, which equals to VBAT, because VCC is 0, and then VBAT starts to drop, so V out starts to drop as well, but then VCC goes up. So at some point here we have 2.45, 2.52, and then V out that's still VBAT. VCC is a little higher, but then there's some hysteresis in the chip, so it won't switch directly to VCC because it might be some transient, some power spike from whatever parasite or whatever, so it just doesn't wait for it to be a little higher. So here VCC is 3 volts. Actually it might actually have, oh no, 2.45, that's a little higher than 2.44, so yeah, it's probably already switched here. And then VCC is 3 volts, and that's almost 3 volts, and VBAT is less than 2 volts. So yeah, V out, that's working. We can probably make the test the other way as well. Not sure it's worth it, but well, let's see. I can probably disable it. I just have to comment the line. I mean, if it takes too long, because each test I had, it just takes some time. So if I have like 50 chips to test, I don't want it to take 10 minutes per chip. So well, minus here, 5, 0 here, 5, 0. So it was a bit painful to code all this ramping stuff, ramp, blah blah blah, but there it's just quite easy to just add another test. So yeah. I think the PFI, yeah, power fail inputs, yeah. So that's done. Let's see. I should probably have some. Well, yeah, I could probably add some debug define or whatever to skip some printfs, some serial printing, but I still want to keep the at least some info, because I mean I probably just test the chip in batch and keep just keep the pass one, and the failed one just leave them alone, and then retest them to see what they actually fail, so I can understand that, like, maybe if this fails, it's because there's some bridge over there or whatever. So then I can have the tester as a standalone device with the LEDs, either green or red. Or but if I want to make just classify which error, then I just plug in on the PC, and I have the serial console to tell me. So yeah, test 3. There I have. So we went from 5 volts, and we're going down for VCC, and VBAT is going up. So V out starts from 5 volts and is mirroring VCC until VCC gets under here, and now it's mirroring VBAT. So yeah, that's fine by me. I mean, it's way enough. And I don't have any warning or whatever. So yeah, let's review this test. So where is it? Yeah, here. So if we're under 525, it means V out should be VCC if VCC is higher than VBAT, else V out should be VBAT. If we're in between, well, if VCC is above 4.75, then well, we should always have VCC as V out, and else we just make sure it's either VCC or VBAT. We don't really care, because it's not a situation that's going to last anyway, because the power supply usually goes from 0 to 5 and from 5 to 0 in a short time, and well, so it's a really transient situation. So yeah, that seems correct. Now I think we should probably also check the reset output here. But then maybe I should test here for VCC if we actually that's the problem. If the reset is actually timed, it doesn't really there's a threshold, but then you have to wait for the for sometime after the threshold is exceeded to have resets going up. That means I should probably have to code this in a way. I could probably have use some state bit here, state mask here. Okay. So the last bit is 7. Yeah. State do ramp, because yeah, the state value is passed on each iteration, but then the ramp function also uses it. Yeah, okay. That's the yeah, that's the iteration count actually. State equals 0. State mask, state plus plus. Yeah, that's it. Should I actually use the last bit for reset or something? I mean, if VCC is above the reset threshold, it means at some point we should get reset going high. So we should expect a transition or something like that. Yeah, MR, the manual reset input, we test separately, so yeah. Well, at least we can test that going below the threshold for VCC actually holds reset down. That we can easily test. And then I could probably encode this in the state variable, but then plus plus. Yeah, that should work. I don't really need any special casing here to increment it, except, yeah, here I need to mask out state mask. Maybe I want to have some, well, let's do this first, and we can always change the state mask. The compiler might complain or something. Why is that here? It's not required anymore. So if we do have a ramp on VCC, if we're ramping down, reset will always go low directly, But if we are ramping up, which means if test if ramp or mosquito alert dot what's the name of the field here, delta. If delta is positive, it means we are ramping up, so it means we are actually waiting for a reset to go high at some point. If measured and measured VCC should probably have some static const float v or st equals, and except I think it depends on the it depends on the chip, of course. Yeah, yeah, I see there are some weird stuff happening at very low voltages because the transistors are barely working inside the chip. But RST response size, response time and such, 5 volts, yeah. Yeah, the output, the RST output is not really 5 volts or 0 because the chip is powered by the input it's monitoring, so it can be really always 5 volts or 0. So yeah, you see it's still working at 4 volts, but then its VCC is below the threshold, so yeah, it should go down, but like 5 microseconds per division, that's 10, almost 20 microseconds. The delay is in milliseconds on Arduino. I never remember. I think it's, yeah, milliseconds. So we wait like for 10 milliseconds or something. Microseconds, okay. We might need to wait some more for this. Oh no, delay is, yeah, milliseconds, okay. There's a delay microseconds. Whatever. So yeah, that's way enough. Assertion, VCC, what? Response time. Oh yeah, there's some of the chip variants actually have a non-negated output for a reset and other pins. Per fail, comparator. Anyway, I was searching for VRST. VRST, it should be somewhere, yeah, reset thresholds. Yeah, so actually it's not a exactly fixed value, so we have to also do some, well, if it's below and if it's above, and then if it's in between, well, it won't stay anyway, so we probably don't want to test for that case. Yeah, so that means I just can't have a VRST value here because there's actually multiple of them. Anyway, between, yeah, if well there how do we if we're going up, well, if measure VCC is just point, I think I used 0.2 or something, yeah, just to make sure, because well, it's really the absolute max value in the datasheet, but there's also some measurement errors on the Arduino and stuff like that. So if but then I should also check that reset is still low, because if it's high, then it probably already transitioned. Yeah. No, I don't want to shift the value by 4.75 bits. Oh well. What time is it actually? Oh, close to midnight already. Yeah. Yeah, I need to I think it's in RST, is it? In RST, yeah. So now there's a trick to go where I want to paste that. Control Z, you cancel and you redo, but at least you're on the line you wanted to continue writing. Digital read in RST, yeah. So if and not so if we are ramping up and VCC is above above the maximum reset threshold, and reset is still low, it means it should transition high at some point. Then I want to encode this state in the state actually. Actually, yeah. Well, if I keep reading that, well, I probably don't need that. I mean, because yeah, there's a delay. What's the actual delay for reset? VCC to reset delay from VCC falling 10 microseconds. Yeah, but that's the yeah, T-rec. That's T recovery reset pulse width. Where are the chronograms? That's, yeah, T recovery. That's from the manual reset, but then, yeah, okay. When VCC is above the threshold, you need to wait for T rec, and T recovery is 200 milliseconds. So that's quite slow. So it can be just after this delay of 10 milliseconds. So it means, yeah, yeah, I can actually do this multiple times as long as reset is low. Yeah. Ah. Oh. Yeah, that's. And then if, well, do I put all the tests? Yeah, that's, I could probably stuff them inside there, but if it's in RST, right? Yeah. If reset is high, it means that we finally reached the point we wanted to wait for. So I need to clean the mess. Tilt equals, that's in exclusive oral, I don't remember. I think that's it, but it's been a while. Not equal. No. Oh well. Oh yeah. Yeah, the bitwise inversion of this, and yeah. So I set this bit to 0, and then at the end of the test, if we are still well, that's the problem, because if we have like how many iterations? 10, and we wait like 10 milliseconds, and we need to actually wait 200 milliseconds. There might be some issue with that. Oh well, if that's wrong. Yeah, that's the problem. Maybe I could keep the bit flag or for the next test, but that's not really clean. Ah well. Oh. Yeah. If measured VCC is below. Yeah, that's doubles the. It's the same test, but well. And I could probably spare the. Oh. So if VC is below the minimum reset threshold, then reset should be low. So if it's not low, let's see what this does. Is anyone watching on YouTube? No, not really. Let's see that. The out should be VCC. What? I got some warnings there. Reset didn't go high. Oops. Yeah, it's probably it's still 0, so we don't wait enough. I should, yeah, I can probably, if we're waiting for reset to go high, I can just do delay another delay, and if it's like 250 milliseconds, then and it's still high, then well, we fail. V out should be VCC, and it's not. Point wide 1 point 0.5499999. I think I just make it like 0.6 because, well, it's a real chip and it's soldered correctly, so it must pass. Anyway, yeah. Test for reset. Yeah. I was about to use sleep, but it's so the recovery max is 280 milliseconds. So let's make it like 300 just to make sure, because yeah. And then if digital read yeah, so if it's low we remove the flag, so here it should not go there. So yeah, that means if did I just forgot something? Yeah. Okay, let's retry this. So the problem with that is we add like 200 milliseconds and the test is starting to be a bit long, but well, failed. So what failed exactly? Missed. So done. What's this? 102? What's that? 102. Reset didn't go high. Yeah, that's it should be VCC again. What now? $197 minus yeah, what? Oh, 2.09. Oh yeah, right. Vout is higher. Well, that's the either measurement error or just the fact that because we are using PWM and stuff, like the capacitor actually takes time to charge up to the new mean value of the thing we wanted to be at. So by the time we actually read V out, then this one VCC probably reached 2.09 as well. And 2.09 minus, but then V out should be VCC. So measured V out 2.209, measured VCC 1.97. Well, that's weird. V out should be, why is that? Oh no, it's this one. Yeah, it's before. So 57.00001. But well, I thought I changed that. Did I forget to? Yeah, it's the only one I didn't change, of course. I missed this one previously, so yeah. Okay, then okay, so this one should work now. Then reset didn't go high. Reset is 0, par fail out. Yeah, okay, that's because VCC and whatnot. Reset reset VBAT. Reset should only depend on VCC, not VBAT or whatever. So reset, and it's really, yeah, it should go high at some point here. So it means we didn't wait long enough. Reset, that's T recovery. Maximum 280 milliseconds. Yeah, that should be it. Didn't go high, so that's the one. If digital read. Oh no! Wow. I should probably go to sleep. It's midnight. Yeah, it did go high, but yeah, the test should be this one. So yeah, if we read a 1, we actually want a 0, and yeah. So if the value read is still 0, then so false, then we get the invert of that. So yeah, the test actually did work, and the chip actually does work. It's just that the test was wrong. Okay, that might work now. Well, yeah, it's just midnight here, so bear with me. Oh, someone posted on this channel. Yeah, I have a look later on. So yep. What's this one? There's some debug output. I'm not sure what it should be here, but well, test 3, test 2, test 1. Well, it seems correct. At least we don't have any error. Maybe I should yeah, I write something when we wait for reset. Yeah. Just to make sure. And then reset should be low. Yeah, it's not too bad. I think we're quite good here. There's a parafill output. I think we don't really, yeah, I just read it, but yeah, we don't handle it. So I think output delay, there's no, I don't think there's a delay for PFO, so we can just add a simple test for it. But what's the threshold? VPFI threshold. When PFI is less than VPFI, or when VCC falls below 2.5, or VSO, which is either something or VBAT. That's painful. Yeah. Goes low, otherwise PFO remains high. Connect to ground if unused. Otherwise before 2.4 or VSO. Well, I don't really plan on testing PFI with VCC changing or whatnot, so the PFI test either I should test it only when we have a ramp on it, maybe, yeah. It's not like it's a test for the chip manufacturer anyway, so a PFI, yeah. So yeah, I think I just do it here. Well. Maybe I could just add it here as well. Well, yeah, it's getting late. I think I just do it there for now, and no, I just want this single channel. Accept. I don't want this. Well, yeah, I do want. Yeah, maybe I could just add a flag here. Check PFO equals false, and then I test later on. So the input values has time to settle and stuff like that. Yeah. Then check PFO. If test PFO, then if measured, I think, yeah, measured, and yeah, I also need to do this. So if why is it? If measured PFI less than what's the threshold already? VPFI. All other versions. Gosh. 1 point. Well, I just get for the get the lowest one and the highest one, and that's 1.20 minus 1.2. So I don't really care in between. I just want to make sure that if it's really below any possible value for the threshold, then digital read in PFO. Yeah. So if it's PFO bar, so yes, 0 asserted. So if it's not asserted and PFI is really so low it should be, then PFO is high, and then, or else, if it's so V PFI 1.3 3 plus 0.2 and not, so if so in theory we should also check for VCC to be above any threshold, whatever, but well, I don't really care for now. Do I print? Yeah, PFO. Okay, expected, and PFO reset. Just measure. Actually, yeah. PFI. Whatever. Let's try this. Is anyone still watching? Of course, we have a compiler error. Test PFO was not declared. What? I called it the value. The variable is check PFO, so it's not test PFO. That might work. Oh, that might work. But then can I do something like time read? Yeah, okay, I can do that. So I can actually see how long the tests run. So PFO is high. Failed. So the only error we have is PFO is high, so it's in the, yeah, did I miss something in the code or whatever? Oh, PFI, that's weird. Or Yeah, that's the thing. If it's actually really zero, then the chip probably considers it to be tied to ground as unused. So then it probably just checks for the reset threshold on VCC. So that's annoying. But then, yeah, that's weird. PFI is high. Wait a minute. VPFI. We shouldn't test for it, right? I mean, do I have a ramp for PFI? Oh, right. -1. Yeah, so we actually always have a ramp defined, even if it's just straight zero. So I can't really do that. I just exclude the case where the delta is 0, because yeah, I'm lazy. Where is that? Where is that? Here. PFI and ramp dot delta. Yeah, if it's non-zero, and if it's 0, it just won't. Actually, no. Yeah, I'd rather have the measurement take place anyway. So. Okay. There's still someone watching? Oh. At least on Twitch. I don't even remember if I actually activated DVR. Yeah, okay, so, well, in case you missed something, there will be a recording available on YouTube. Reset mode high as expected, yeah. Passed, yes, that's great. So we still have the we still have PFO, yeah, PFO going up here, but well, we explicitly don't check for it. But then here we have PFI, which is going up, and we have PF power fail output, which goes up. Also because we, for this test, we always keep VCC to 5 volts, so well, almost. So yeah. So so if we want to check for PFO, if it's way below and PFO is on, then it shouldn't be. If it's way above the threshold, well, it should not be 0. Okay, well, that's not too bad. Now I want to know how long it takes to test a single chip. So I will just run the shell with time read. I'll press enter when starting and enter again when I see it stops. And it's slow, and it's slow, and it's slow. 9, well, there's my reaction time, but yeah, like 16 seconds, that's a bit too much. Maybe I can guard some stuff with preprocessor. Not the serial.print. To write out MR. What's that? Oh yeah, okay. Serial.print. And then that's an error. That's an error. Serial.print or wait. Oh, actually, we do 100 milliseconds. Yeah. Why did I do that? Probably because there was some stuff that didn't work when it was, yeah, I think some other test, maybe MR? I don't think so. I can probably fix the MR test to explicitly wait for it, just like for a reset, because I don't want to wait 16 seconds. Anyway, let's oh yeah, around that delta. Why I don't need that. If state, it should compile without this, so let's try that. And then yeah, so the ramp, actually all the serial output for the ramp stuff, I just guard it with if debug, if def. Yeah, so let's see if it's any faster already. Do I still, yeah, still have the mic working. That's great. Terminé, okay. So Where's my terminal? That's still way too slow, but well. $15 seconds, 0.7. Yeah, that's like half a second shaved, or maybe not, because I'm quite slow to press the enter key anyway. So that, well, that's debugging output anyway, so which I don't really need. I thought I removed some tabulations there. Maybe not enough. Yeah. Actually, yeah. So let's have that and see if it works. Advertisement. Yeah. Oh, failed. What failed? PFO is high. Okay. Power fail. PFO is high. Yeah. So. Oh, right. So there's a delay with PFO. What the? It says 0. What the? What happened? That should not be. The first test is not this one. Rams PFI. Out. Sorry. Test 1. Test 0 done. Oh yeah, okay. It just stopped at the first. That's weird. PF is. So should I? Yeah, that's again this ground the input if not used or something. Maybe if I if I check if where is that? I think if it's like if PFI is less than 0.2 or something, 0.1, I'll just ignore it. Unless there's a delay. PFI to PFO propagation delay 2 microseconds? No. We wait like 100 or something. That's weird. Test for PFI. Um, if less than 0.2, yeah, so maybe I could just yeah, let's try this way. Damn. Sore throat in middle August. That's weird. Yeah. Too late. Oh well, that's failed again. What? PFO is high. Ah, really? That's weird. Why is that? That's annoying. Point 43. It should take that long to propagate, but well. PFI to PF 2 microseconds. Typical, yeah, but it can be 200 milliseconds. That's PFO output short to ground current. Okay. Output threshold. That's weird. Anyway, did it actually compile? Yeah. 10 seconds or so. Yeah, it's a little better. And we passed. Okay, so yeah, that's really weird. Reset. Oh, okay, so that's probably because yeah, that's weird. Maybe it's just because that's the first test we do, and the chip just is starting up. You see there's a reset that still hasn't raised. and since we are shortening the time on each ramp, and so we're starting to see stuff that we didn't see before. So yeah, well, for now it works. Let's see if I can make it even faster. Let's say 10. Let's try it. Who knows? So I wanted to also do the writing for the proto shield, but that's going to be for another day, because yeah, done. Ooh, lots of errors, of course. Fail, yeah, less than 10 seconds to fail. Vout should be VCC. Yeah, that's the problem. Vout should be VCC 4.20. Ah, right. That's the problem. That's the problem is with the capacitors. Since we're doing PWM, the capacitors don't have the time to charge up to the mean voltage of the signal. So we're measuring stuff when we're while we're measuring stuff, we'll see doing weird changes. So yeah, I can't really do as fast as this. Still, I could probably because for each ramp I actually changed the signal for each channel independently. Maybe I can, instead of yeah, that's the problem, because then later I'm reading stuff here right after changing the ramp. I should probably delay reading these. Also, VCC, there's always a ramp for VCC. Yeah, I should just move these to after the delay here and have a larger delay here, but a single one instead of having one delay per ramp callback. Yeah. Should probably commit this. I mean, let's make sure with 50 it's, well, let's just go with 100 here anyway. Modified, yeah, okay. Tests. Okay, so at least I have a version that does work, just to make sure it still works. Oh, went high as expected. Yeah, okay. Well, passed. Okay, 15 seconds times 50, that's divided by, well, 60 seconds. Yeah, like 10 minutes, 12 minutes. Yeah, okay, I can probably I probably won't be testing 50 chips at once anyway, so yeah, it's probably still manageable. I mean, I can just do that reading mails or something. It's just like every 30 seconds you have to remove the chip, and oh well, that's probably still manageable. Yeah. Because here we that I can leave it here, because the test well, see, there's always the same channels activated anyway for each round, so I don't really need to do it conditionally here. So it's just that another channel. Yeah, I know which another channel is VBAT or whatever, so I really don't need this. Yeah, here I will just need to add a flag to test for, just like for test PFO, check RST. That's, yeah. But then so here I can remove it and wait right there, and that simplifies the code as well, probably, because measured measured VBAT equals blah 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 blah, and yeah, let's remove this condition. I need to check. Wait. Yeah. Okay. Okay. There's this test here. If so, then the other test will be just this part, but not here. It will just be somewhere here after we measured VCC, and then PFI in PFI max. Oh yeah, right. There's this one. If expected, actually I don't use it, right? I mean, yeah. So let's drop that. So that means one less if statement. less useless comments, and yeah, that's cleaned up. So that should still work as is. Wow, Firefox is stuck slow. Replay. Oh, Big Bad Biologist on Saturday. Oh, that's tomorrow. Oh, great. So, if you don't know the Big Bad Biologist and his Big Bad Bench, you might want to check that out. Tomorrow he will fiddle with 486s, this one, and overdrive CPUs and revive 2 dead 486s. Wow, that's tomorrow on YouTube. Yeah, in like 17 hours. Let me put that in the... Hey, Virtual Lab. How are you? And the code doesn't compile, of course. Ah, well. Well, I'm fine. I'm at the Fabrico, and I'm trying to finally finish something I started months ago. To to test some replacement chips I made for old Macs using a small PCBs the size of a SOIC chip with a SOIC chip on it. And I just noticed a yeah, okay, the large cam is frozen again for a change. Anyway, I'll just go like that, but yeah, that's the replacement chips. So it's basically a SOIC 8 chip on a SOIC 8 size PCB, but then I need to test them before I sell them. So I designed this stuff here with an Arduino and some code, and next I'll have to make a proper proto shield instead of all this wired mess. But yeah, I wanted to finish all the tests. The tests I wanted to run on the board. What now? Check RST and blah blah blah. Was not declared. Oh yeah, right. I forgot to check to define the variable. That might help, right? So yeah, Big Bad Biologist tomorrow. It's not the Big Bad Wolf, Oh, it's on. He's on Mastodon as well. Wow. Big Bad Biologist at bitbank.social. That's great. Let me follow him. So did it work this time? Yeah, it worked. Let's go back to the screen sharing. So I'll go ahead and testing. Test 3 done. Okay. And yeah, 15 seconds. We're still at 15 seconds. But then maybe I can now remove this delay here. Probably need some larger delay here, but make it like 100. So in case you missed the start and well you want to watch it, it's relatively boring, but anyway, it should be recorded on YouTube, so you can go back there. The live, I think I posted the link on on Mastodon and others. Terminé. Yeah, that's it. So again, that's I think much faster, right? 12 seconds. Yeah. I think I just leave it here. I mean, yeah, that's like, well, 10 minutes playing. Well, it's weird because, well, it's probably not that much this delay that slows the thing, that rather the all the serial.print. But then if I want to actually know what's wrong with the chip, I need to keep it. I can probably remove some of the stuff, but well, or maybe just yeah, maybe I could just print it only if there's an error or something, but I think for now I just leave it that way. So yeah, let's commit this version as well. Yeah. Okay, so now if I like start the test and I do like force the manual reset, it should yeah, okay, it's only on this test, but yeah, so it fails and I have the red LED blinky blinky. Like if I yeah, here I just lifted some of the contacts, so just while testing, so it got confused, and yeah, it failed something at least. Yeah, so that's great. And if I just remove the chip, it should fail. Yeah. Actually, why do I should be low? There's probably no need to test everything if there's a failed test, I suppose. If we finish all tests, yeah, it's probably faster to just bail out completely if something failed. Because like if I just push the button and there's no chip to test or whatever, I don't want to wait 15 seconds or well 10 seconds now. Damn, I found a broken Kobo e-reader and maybe bought it. Virtual ad. Yeah, should stop buying stuff. Ah well. But then where's the fun in that? I don't. Oh, okay. Oh no. Oh, okay. I think there's some error. I just hope it's not like because of the webcam or something. Did I touch it or? Let's try again. It worked fine, so or maybe yeah. I don't know. Anyway, yeah, it's 1 a.m. I should probably finish there. Terminate. Okay, it's done. That's weird, but well. So here I don't have any chips, so yeah, it failed. It just fails immediately. So it doesn't even attempt to do the other tests because there's no point in that. If I just push the lever here, if I just remove it actually and short some pins, it should fail as well. Yeah, so just bails out. Yeah, I'm so let's switch to the endoscope. Shout out to Virtual Labs. He recommended the this thing. Where is my this thing here, which is an endoscope supposedly for ears, but it works quite well. I used it the other day to unstick some window on the building which were just stuck from 60 years of paint or something. So I found where the paint was. I just cut it. Yeah. So endoscope and where's the bottom? Yeah. So let's just put the chip to test here and there, and I need to push it while installing because I don't want it to drop. So yeah, now it should be secured on the slot, and I just run the test. Blinky blinky, blinky blinky, blinky blinky, So it blinks for each test, and it's passed. Yeah, great. So it works. I have some, I think I have like 6 or 7 chips that already soldered, that I can test maybe tomorrow. I did send 1 or 2 to Joe of Joe's Computer Museum for testing, like, I don't know, 3 or 4 or 6 months ago maybe. But then he's busy as well, so it's okay. I mean, it's been like 6 months I didn't touch this. So yeah, but I'm waiting for him to test it in yeah, Color Classic or something, because I know the power fail input is actually used inside the Color Classic and not inside the Mac LCs. So just to make sure they also work in this machine. But yeah, so let's wrap up. So we added a lot of useful tests to this testing framework, and so now I can actually test the stuff I solder for this project, and this means maybe I can open a shop someday because I can sell them. Anyway, thanks for watching, and well, see you later. Don't forget Big Bad Biologists stream tomorrow, and also on Sunday there's Dave's stream. Dave's Vintage Apple Tech. That's the wrong window. I sometimes appear on the stream on Sundays. So you may, yeah, and there's always a lot of stuff happening. People testing stuff, fixing Macs and other stuff. So if you don't know what to do on Sundays, it starts like at 5 p.m. my time. So so if you want to have a look, yeah, it's there on YouTube. And yeah, I think I'll end up here. Thanks for watching, and yeah, see you later. Bye.